that the rest of Canada was covered with 2 miles of ice, and the Arctic was not covered any more than it is today. Well, the reason, I think, and we can get into this later, but I think it has to do with underwater volcanoes.
Yes, and in your book you talk about, it's called volcanism. I keep thinking of Star Trek when I hear that word. That underwater volcanism has a huge impact on our weather. I don't understand that. That's wild. Explain it.
Well, if you think about El Nino, is during an El Nino, the ocean warms up on the Asian side of the Pacific. The Pacific warms up, and then that heat travels across the Pacific, and when it comes to the United States area or to South America, it creates these giant rainstorms, because as that area of the ocean warms, it sends ever more moisture into the sky. You mentioned clouds at the beginning of this. Well, that heating ocean is what sends all the moisture up there to create those clouds, and it comes to us as giant rainstorms.
But how does the volcanism impact weather?
Well, because the underwater volcanism heats the ocean. You know, I hear about humans heating the ocean, and yet the ocean, the heat begins at 2 miles down. I do have a paper on my website that shows that scientists have found that the heat begins at 2 miles down. Now, I don't know how we humans can be heating the ocean 2 miles down before the surface heats. Anybody who has a swimming pool, if they've tried to heat their swimming pool by blowing a fan over the top of it, they know it doesn't work. It has to come from the beneath.
So the ocean is primarily warmed from down 2 miles deep. And ocean warming, if I'm understanding your books and what you're saying, ocean warming also plays a role on weather.
Oh, it controls the weather. It controls, and I don't understand all of it, and I think when we have Joe D'Aleo on, the meteorologist, we'll learn more about that. But yes, because it controls the jet stream, everything about our weather comes essentially from the ocean. As you said earlier, is run even before that from the sun.
Okay, ladies and gentlemen, please welcome Joe D'Aleo. He is the owner of icecaps.us. He's a meteorologist. He is a person who's articulate and committed to getting the truth out about weather and climate. He has a extremely popular site, icecaps.us, with millions of people going to it. Joe D'Aleo, welcome to It's Rainmaking Time.
Thank you, Kim. And I would like to follow up on what Bob has said. He did talk about the ice in the Arctic and Antarctic and volcanism. And the Arctic ice has indeed diminished in especially since 1999, and reached a record in the satellite era. During the period from 1979 on, we've been able to see the Arctic ice and measure its extent. And we had the least amount of Arctic ice in 2007, and they made a big deal about that. But you haven't heard that it has recovered quite a bit since then. This year, at the minimum, in September, we were 26% more in our extent of the Arctic ice than in 2007. So it has come back. Now, the Arctic ice is floating on water, unlike the Antarctic ice, which, for the most part, is on land. There is certainly some sea ice in the surrounding waters. But it is subject to melting from beneath. If the oceans in the Atlantic and Pacific are warm, and some of that warm water can make its way underneath the ice, and it does, the currents carry that warm water under the ice, it thins the ice, and you wind up with a smaller extent, thinner ice that melts during the summer but comes back during the winter. This is not a new phenomenon, though. As Bob has said, there's cycles and cycles, and there are cycles in this Arctic temperature and Arctic ice that have been observed. The 1930s to 1950s, we had similar reduction in the ice in the Arctic. Also back in the 1800s, when the Siberian oceanographers and fishermen tell us that they caught codfish off of Siberia in the Arctic. So This is not an unusual phenomenon. It does not relate to CO2, but does relate to ocean heat. In the Antarctic, as Robert said, the ice has thickened, and in fact, the total extent of the ice, according to those same satellites, has reached a record maximum in 2007. Since 1979, and the melting last year was the smallest ever on record, and we continue about a million square kilometers above the 31-year average in the Antarctic ice coverage. When it comes to volcanism, volcanoes affect the climate also by spewing ash, but more importantly, sulfur dioxide high into the atmosphere. And when it gets high up, 80 to 100,000 feet or more, it has a long lifetime, and it quickly gets converted to what we call sulfate aerosols that act like little mirrors to reflect the solar radiation that comes from the sun back to space, and the result is that less sun energy gets through to warm the surface, and we wind up with 3-4 years of cooling, and that's been clearly seen in the temperature records in the 80s after El Chicon and Mount St. Helens, and in the 90s after Pinatubo. In times of very low stratospheric or high-level sulfate aerosols, like we've had in the early part of this decade, the atmosphere is cleaner and more radiation gets through, and we wind up with a warming. So some of the changes that we've seen in the last 2 decades can be explained by volcanism in the atmosphere.
Why do you think, not to derail the scientific part of this, but why would something NOAA, and can someone explain who NOAA is?
They're the National Oceanographic and Atmospheric Administration. That's our government agency responsible for studying and reporting data on the oceans and the atmosphere.
Okay, thank you. You know, they say, NOAA has said that 80% of volcanoes are actually underwater. I didn't know that. I don't think the public would know that. So when you talk about volcanism, volcanoes being a key, one of the keys, impacting climate, I'm stupefied that it's off the table of human consumption and awareness as being a huge impactor of, warming the oceans, but also altering weather.
Kim, can I come in on that?
Please do.
Okay. Because when NOAA said that 80% of volcanic activity occurs underwater, I first heard about that in the early 1990s when I began researching for the book. But, that was in 1991. In 1993, at that time in 1991, NOAA thought there were about 10,000 underwater volcanoes in the entire world. That was 1991. 1993, they discovered another 1,133 underwater volcanoes down off the coast of Easter Island. They were shocked. So they increased the world's supply of underwater volcanoes by 10% in just a matter of months. They also discovered underwater volcanoes, rift volcanoes off the coast of Oregon, off the coast of Washington, that they weren't really aware of. Now that was 1993, so they thought there were 11,000 underwater volcanoes. Now, if you visit NASA's website, they estimate that there may be as many as 3 million underwater volcanoes. It is incredible how the knowledge has changed since 1991.
Well, do you think, I guess my question on this is, and I just want to stay on it till I have a clear sense of this for the public, if that's true, even if it's true by 20%, isn't that going to impact ocean warming critically?
It has to impact it. There's... And the fact of the matter is that volcanism has increased. My understanding is that above water volcanism has increased in the last 100 years, and that if underwater volcanism has increased, I would assume that, if above water volcanism has increased, I would assume that underwater volcanism has increased even more. So what we're looking at is that the above water volcanism is pouring ash and sulfur and everything else into the sky, which is cooling the skies, while at the same time the underwater volcanoes are heating